Today we're going to be talking about isosceles and equilateral triangles and the special properties associated with these triangles. Okay, so the definition of an isosceles triangle is a triangle with at least two congruent sides. So technically it can have three congruent sides. That's a more specific case called an equilateral triangle. And just as a reminder, the base angles are opposite of the legs, which are the two congruent sides, and the base and the vertex angle. And the vertex angle is up here, and then you have your base angles down here. Okay, isosceles triangle theorem. If two sides of a triangle are congruent, then the sides opposite those angles are congruent. So, if in our diagram, if AB is congruent to AC segments, then angle B is congruent to angle C. And that is ITT. And you need to understand the difference between these. Okay? You start with your definition. How I remember it, I should say, is you start with the definition. Okay? It says something about sides. So that's how I remember. If two sides is the original version, ITT, versus the converse. The converse is also true. So if two angles in a triangle are congruent, then the sides opposite those are congruent. So if angle B is congruent to angle C, then AB is congruent to AC. So this is the converse. I start with the angles, then I go to the sides. And our abbreviation is CITT, if I were to use that, say, in a proof or giving a reason. Okay, number 1A. Name the congruent angles. Okay. So if you look in the big triangle, JMK, this side is equal to that side. So JM is congruent to LK. So therefore angle LMK is congruent to angle LKM. So these, I'm going to say these big angles are congruent. Now notice what we have here. We have this smaller angle congruent and that smaller angle congruent. And there's two smaller angles that sum up to equal that big angle. So that other angle that adds to be the bigger angle, those are also congruent. So angle LMP is congruent to angle LKP. Okay, naming the congruent sides. I'm going to erase all this because it's not really going to help us. Okay, so I know that angle PML and PKL are congruent. So in this triangle, let me actually highlight it in red. In that triangle, PM is going to be congruent to PK. And I don't think there are any other sides that we can say are congruent. I shouldn't mark those with 1. I'm going to mark those with 2. Because I just thought, oh, maybe there's one of them. No, I don't think there's anything else that we can say are congruent by using this isosceles triangle theorem. Okay, properties of equilateral triangles. And I already talked about this in an earlier video. An equilateral triangle is also equiangular. And that makes sense because if this side is equal to that side is equal to that side, this side and this side are going to make these two angles equal. This side and this side are going to make this angle and that angle equal, which gets them, all three of them, to be equal. Equilateral triangle has three 60-degree angles. We proved that in a previous video. And equiangular triangles are also equilateral. And that's kind of, it's almost the converse of this original one, this first one. And again, you can prove it pretty easily with, okay, equiangular, this angle's equal to that one, so that gets me those two sides equal, but that's also equal. So since I'll use this one and that one, that's going to make this side and this side congruent, making them all congruent. Okay, angle 2. Solve for angle T and TS. Okay, so I know this side is congruent to this side. That means that this angle is 60 degrees. Well, I have two 60-degree angles. All I have left over is 60 degrees, making this also be 3.5, since equilateral triangles are also equiangular. So angle T is equal to 60 degrees. TS is equal to 3.5. Okay, in this example, okay, let me look and see what I have here. I have this angle here congruent to this angle here. So F is congruent to E. So that means that DF and DE are congruent. And DE is also equal to FE. So again, this is that case of, hey, this thing, it doesn't look like it from what the original markings, but this is also an equilateral and equiangular triangle. So I know that 4x minus 8 has got to be equal to 60 degrees. I did this such a more complicated way in my notes. I add and I get a 68. X is equal to 17. We know that these sides are equal, so 6y plus 3 is equal to 8y minus 5. I'm going to subtract these 6y over to get a 2y. I'm going to add the 5 over to get an 8. That gets me y to be equal to 4. Okay, this proof. This is a pretty interesting proof, a fairly challenging proof. Let's mark up our diagram. We know that FG and FJ are congruent, and we knew HF is congruent to IF. I'm trying to prove HG, this little piece there is congruent to that little piece there. Okay, so let's first write out our given. We always start our proofs by writing out the given. Now take something that you know from the given. Okay, we're in our isosceles triangle, so angle G is congruent to angle J. Okay, let's look at this also. Okay, it would be nice if I could get triangle FGH congruent to triangle FJH. Right now I have side-side angle, and that's not a way to prove triangles congruent. So I need to get another angle or another side congruent. I need to get another angle congruent. I'm going to put some numbers in here. I'm going to put in 1, 2, 3, and 4. Again, you can always add angle numbers into your diagram. And that doesn't even become part of your proof. Okay. I used this part of the given to write this statement. I'm now going to use this part of the given to write another statement. I'm going to say angle 2 is congruent to angle 3, also by ITT. I'll kind of highlight this so you see. Now let me explain to you my thinking here. I know these angles are congruent. 1 and 4 are supplements of congruent angles because 1 and 2 form a linear pair, 3 and 4 form a linear pair. Okay, and so since 1 and 2 form a linear pair, 3 and 4 form a linear pair, 1 and 2 are supplementary, 3 and 4 are supplementary. We know that supplements of congruent angles are congruent. And I know it's kind of a deep pull for some for some theorems, and that's why that makes this kind of a challenging proof. We know supplements of congruent angles are equal, so then I could get 1 equal to 4, and that would get me side, or would get me angle side. Wait, no, I can't do that. I didn't see it right away. That would get me angle side. Ooh, dear. So I need to get angle 1 congruent to angle 4. So let's talk about how we're going to do that. And I kind of already did. So I can say angle 1 and angle 2 are supplementary. Angle 3 and angle 4 are supplementary. And that is our supplements theorem. Supplements of congruent angles. 2 and 3 are congruent. So supplements of congruent angles are congruent. So now I have our triangles congruent. By angle side, and then I can finally say HG is congruent to IJ by CPCTC. Again, that was a little bit more of a challenging proof, but you have to know all the theorems that we've talked about in class. But I wanted to show you guys a proof involving this ITT and CITT. Thank you for watching my video on isosceles and equilateral triangles.